Before we move on to positive and negative decimals, we need to do a really quick review over just regular non-decimal numbers just to make sure we remember what we're doing. So I'm not going to belabor this one for too long. Positive 5 plus positive 3. This makes a little model here. You see if we drag little black ones into the middle, each little black chip represents one positive. See right here how it tells me that this is equal to 3 if I pull in 3 positives. Well, and then I'll bet you could probably guess that the red ones with the little negatives on there represent negative numbers. So this, for example, is a model of a negative 3. Well, you've been doing this one since you were little kids, and I'm sure your teachers in the past had you use some kind of manipulative for something like this. If I'm going to make a model of a positive 3, oh my gosh, why won't that go away? He really just does not. There we go. So positive 3 plus a positive 5. So, of course, I'm just going to pull positive 5, 3, 4, 5. Then I'm going to add 3. Of course, positive 5 plus positive 3 is a positive 8. Totally get it, right? Well, it works the same way. If I were going to make this a negative 5 and a negative 3, still works the same way, except now I'm going to pull negatives in here. So there's my negative 5 plus a negative 3. Well, what's a negative 5 plus a negative 3? You guessed it, a negative 8. If they're the same sign, whether it's a positive 5 and a positive 3 becomes a positive 8, or a negative 5 and a negative 3 becomes a negative 8. If they're the same sign, all you do is just add them together. A real life example you could think of is if you owe me, remember when you owe somebody money, that's a negative. So let's say you owe me $5, then you owe your best friend $3. Well, you're in the hole a total of $8. So, easy breezy. If they're the same sign, you just add them together, keep that same sign. What if they're not the same sign, though? Something kind of cool about these little manipulatives is that if you pull a positive and a negative over here, poof, they vanish because a negative one and a positive one are going to cancel each other out. If you have no money whatsoever and you owe me $1, that means you're worth -1 right now. Then you find $1 on the street, so now that's a positive one. Hopefully you'll take that positive one that you found on the street, give it to me to cancel out that negative one, so now you're worth a total of 0 again. Okay, a positive number and a negative number cancel each other out. We've talked about this. It's called the additive inverse property, where the opposite numbers cancel each other out. So that helps us to figure out what we would do if we're adding together a positive and a negative number. And why the dickens do these not want to stay common? Okay, well, I'll just use this one as part of my example then. So let's say we've got a positive 5 plus a negative 3. So for my model, I need a positive 5. 1, 2, 3, 4, and a 5. I've got a negative 3. So I'm going to pull out in 1, 2, 3 negatives. So these positives and these negatives are going to get together and poof, cancel, poof, cancel, poof, cancel, which is going to leave me with a positive 2 left over. So if they're a different sign, whichever one you have more of, I happen to have more positives than negatives. So I know that my answer is going to turn out to be a positive, because once they do their little canceling thing, I'm going to have more positives left over. Let's do one more quick example. Let's say -8 plus a positive 6. So I need -8 here. 1, 2, 3, 4, 5, 6, 7, and 8. And then positive 6. I've already got 2 positives. 1, 3, 4, 5, 6. Well, if these get together, poof, that one's going to cancel. Poof, 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 and poof, which is now going to leave me with a -2 left over. So this time, because I had started off with more negatives than I did positives, those are going to cancel out and leave me with more negatives left over. Okay, so we went through this pretty darn fast. This is just intended to be a review. Let me know if you need some more examples. And I am going to show you a really quick YouTube video that, yes, the song is kind of annoying. I've shown kids this song for years and years and years, though, and it gets stuck in your head. And I swear it really does kind of help to do it when you don't have chips or manipulatives or something like that. So here goes.
Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact. Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact. Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact.
So I know that guy sounds kind of creepy. So, but it really does kind of help to make sense about what he's talking about. So let's take the lyrics of the song and see how they can help you to do a math problem. So let's say that we've got ourselves the problem, and we're going to get this out of the way here. Let's say we've got a positive 12 plus a negative 8. Well, if they were the same sign, you would keep and add, but they're not. They're a different sign, so you're going to subtract. 12 minus 8 is 4. Now, what I don't like about the lyrics to that song is that it says, take the sign of the bigger number. And I'll tell you why in just a second I don't like that. Now, this time, it does so happen that 12 is the bigger number. So now it'll be exact. Okay, so there we go. It's a positive 4. The reason that I don't like it is for problems like this one. Let's say we've got a negative 17 plus a positive 5. So they're not the same sign, so you don't just keep it and add it. They're a different sign, so you subtract. 17 minus 5 is 12. Now the lyrics to the song say take the sign of the bigger number. Technically, a positive 5 is bigger than a negative 17. So it's not actually the bigger number. What he really means to say, but it doesn't sound very good for the song because it's got too many syllables, is absolute value, the one that has the bigger absolute value. So, but that sounds kind of awkward. Take the sign of the higher absolute value, say it's just too many syllables. So that's why they keep it, take the sign of the bigger number. So now it's going to be a negative 12, and all that means is just that once you put that positive 5 and that negative 17 together, you're going to have more negatives left over. So that's why your answer is going to be a negative.